Okay, I don't know what that's for. Gone. All right, so last application of vector addition that we do in this course is velocity problems. So that's what we're at today. Now, I have a word problem here, and we'll deal with it on the next page, but I do have a list of details worth knowing, so things you need to know about velocity. So I'm going to put it back to big screen so it's easier for you guys to read and easier for my old eyes to read. So the questions look like this. Mandy steered her plane in the direction of north 63 degrees east. And I don't know why I've changed it here, but this is the question. We'll deal with this in a second. That's one of the details worth knowing. It's at an airspeed of 524 kilometers an hour. There was a wind blowing at 78 kilometers an hour from, and that matters, north 62 degrees west. Oh, there it is. Determine the plane's resultant ground velocity. So there's some things you need to know. First of all, there's two ways of me telling you direction. I believe that north being 0 degrees is a ship direction, as in once upon a time, people in ships used the North Star. So that was their bearing, or that was how they arranged themselves on the globe. So north is typically 0 degrees. The second way is this way. So north 62 west means 62 degrees to the west side of north. So if you look, and I'm going to draw a line, and hopefully this will work as well as I picture it will be. So here's a line that's going north, and then north 62 degrees west means that you take this line and you swing it in the west direction by 62 degrees. That's what that means. And this is the exact same thing as straight up 298 degrees. And the reason is because if you count north as 0, which is typically how it's done, when a degree measurement is given without reference to the compass rose, so without the north, south, east, west references, then you're supposed to rotate clockwise. So that is with the hands of the clock. So this way, you're supposed to rotate clockwise. And if all the way to here is 360 degrees, and this is 62, if you subtract them, that's the 298 degrees. So they are actually the same thing. So there's two ways of saying the same measurement. I believe the difference is whether you are flying a plane or whether you are originally in a boat. So that's the first detail worth knowing. The second thing is a definition, and that is definition of airspeed is a plane's speed relative to the air, meaning that if there was no wind, this is how fast the plane would be going. And then last of all, and actually I'm lying, it's not last of all, there's one other thing. Ground velocity is the plane's speed and direction, and that's because velocity is a vector quantity, so you need both the number, the magnitude, and the direction, and it's relative to the ground, which is why it's called ground velocity. So it is the resultant, so it's the result of the wind's effect on the plane's airspeed and heading. So basically, the plane decides that it wants to fly in this direction, but there's a wind, so it's got to actually go in this direction, so the wind veers them off course, or I guess on course. So the mathematical formula for that is airspeed plus wind speed equals ground speed. And I've got that here, and the way I look at it is OG, which seems a bit ridiculous. Another way you can look at it, because of the commutative property, meaning you can rearrange for vector addition, is wind speed plus airspeed is equal to ground speed. That's not usually how you draw the triangles based on the word problem, but it is a true statement. So WAG and OG. So here's the airspeed, here's the wind speed, so here is the direction the pilot is flying so that the wind pulls them to the course that they actually want to go to. All right, so back to the word problem. And this is the other thing I'm talking about. So Mandy steered her plane in the direction of north 63 degrees east at an airspeed of 524 kilometers an hour. So it's telling you the airspeed. So what I'm going to do is I'm going to start to draw a picture. And my advice, like always, is draw large pictures. Now, off to the side, I need this. Just to keep it straight, so I don't have to overthink when I'm doing the question. So the first thing I recommend you do is you draw a gigantic, and actually I'm going to change the colors here. I recommend you draw a gigantic grid. So don't try to crush stuff in here. And although it is an XY axis, because it's north, south, east, west, because it's north 63 east and north 62 west, I'm going to leave more space on the top of this grid than the bottom, just because I can sort of see that happening. All right. So the first thing I want to do is I want to deal with north 63 degrees east. So here is a vector. Here is a vector that is going to the north, but I need to veer it off 63 degrees in the easterly direction. So this number right in here is 63 degrees. Next thing, there is a wind, and that's 524 kilometers an hour. But I don't want to just dump it onto the picture anywhere. I want to make sure it's kind of on the outside of the triangles we make. So I'm going to leave it here and move it into place in a second. Now this from. So if the wind is coming from north 62 degrees west, what that means, and it's 78 kilometers an hour, so that means it's a shorter line than we had before. That means that I actually have this arrow in the wrong direction. So hang on, bear with me for a second. So north 62 degrees west is like that. And what I need to do with this is I need to fling it around. So it's coming from that. Now, if this is the airspeed and this is the wind speed, I should move that here so it's airspeed plus wind speed is equal to resultant, which is ground speed. And I'm going to make that red because it's the resultant. So let's try to find some values in here. First of all, I'm going to put this here. I'm going to put 78 kilometers per hour here. Another thing I can do is I can replicate this and put it back here because I know that this corner is the 62 degrees that I had to veer off in the westerly direction. That means this corner is 62 plus 63, and 62 plus 63 is 125 degrees. And if that's 125 degrees, parallel line, Z rule, that makes this 125 degrees. And I am looking for the resultant, which I'm going to name ground speed. Another thing that I'm going to have to find, and I have to find a number in the triangle because I'm using sine and cosine law, is I am going to have to find this corner because the resultant is related to the compass, and that's where the compass center happens. So let's get at trying to figure this out. I'm going to try to use this space. I'm going to use red first of all to find ground speed, and here's my side, angle in between side. So ground speed squared is equal to 78 squared plus 524 squared minus 2 times 78 times 524 times cos 125 degrees. And I'm going to calculate that and then take the square root. And notice how I'm using really great notation. I'm still using vector notation, and I'm saying I'm finding the magnitude. So calculator. 78 squared plus 524 squared minus 2 times 78 times 524 times 125 cos equals, to finish it off, very gigantic number, 327. Five, 4, 6. 4, 3, 2. I think it was 1, 1, not that it matters. Oh. I'm going to write it down. I should probably be exact, if not messy. And now I square root it. And I get 572.3. So that is the ground speed. So now I know how fast this plane is going. Hold on a second. Totally needed a big sneeze. So now I know how fast this plane is going. So it kind of makes sense that if the pilot, Mandy, steers her plane in this direction at 524 kilometers an hour, and this wind comes sort of kind of behind her, not directly behind her, but at an angle behind her, it'll push her off course to the course that she actually wants, and she'll be faster. So to me, that makes sense, even though I have no pilot experience. So I'm going to put that there, because now it shows me that I can use the cosine law to find my theta. Now, I'm going to make it pretty obvious, so I'm going to change colors and go blue. So sine 125 over 572.3 equals sine theta over 78 kilometers an hour. So kilometers an hour, degrees, degrees. And I need sine theta, oh, don't know what happened, equals 78 times sine 125 degrees divided by that 572.3. And eventually I'll need second function sine. So the nice thing is, this calculator and most let you just punch stuff in. 125. So see me if your calculator's not cooperating with the order. So there's my decimal. Trig, second function sine, is 6.4 degrees. Now that is not our answer. Oh. So don't get really excited. I say with a smile. So this corner here, this is frustrating me. This corner here is 6.4 degrees. But we want to know the bearing either in relationship to the compass rose or from north is 0 degrees. Now, because this is with respect to the compass rose, I'm going to do my answer with respect to the compass rose. So, what you have to do is you have to imagine that you've got a line heading north, and you have to veer off some amount from north to get to this red line. And hopefully you can see that this is 63 degrees to here, and then an extra 6.4. So, with respect to the compass, not with respect to the triangle, but with respect to the compass, the corner that you care about is 63 plus 6.4, which is 69.4 degrees. So, when I go to write my therefore statement, it'll be north 69.4 degrees, and we're heading off into the east direction. So we can now say the ground velocity, so the specific velocity, you can't just say velocity. So the ground velocity is 572.3 kilometers per hour at that. So now we have exactly what we need for the ground velocity, a vector quantity. We've got a magnitude and we've got a direction. All right, time for a little hand cramp break. I shall be back. Okay, so keep in the back of your mind, air plus wind equals ground. So if I read through this question, north blah blah blah, north blah blah blah, north is up, so I'm going to leave it there. So plane starts out from Montreal, heading north 40 degrees east. So there's north, 40 degrees, 45, 40 degrees east, with an airspeed of 500 kilometers an hour. So keep that off to the side. And this is 40 degrees. It also means that you could scribble 50 in here, but usually airspeed plus wind speed equals ground speed, so I don't want to really write in that area. I will put this here eventually on one side or the other. All right, next of all, determine the ground velocity if there is a wind of 100 kilometers per hour, so shorter than the 500 kilometers per hour vector, from north 30 west. So I'm going to draw my wind speed here, badly, with a ruler. So it's from north 30 degrees west. So I'm going to write a little 30 in here. Remember that that's 100 kilometers per hour, which I'll move into place in a second. And I don't really want wind speed plus airspeed, even though that's 100% correct. The reason I don't want that is because then my ground speed, this is perfectly correct, is not sitting centrally located with respect to the compass rose. So I'm going to take this one, leave it where it is, clone it, and move it up here so that airspeed plus wind speed equals ground speed. I am going to turn this into a red line so you can see that it's the resultant. I'm going to pull my 500 kilometers an hour there. I'm going to put my 100 kilometers an hour there or there, preferably here because now I have a triangle. I'm going to dig out my red pen for consistency. This will be my ground speed, ground velocity. And it says determine the ground velocity, so I need both the length of this line, which is the speed, and I'll need this, which I can add on to 40 to find out how far from north I've actually flown. So, red pen. Ooh, do you see what I'm missing? 70, Z, 70. Cosine law. I just kind of assumed it was. Don't assume. If you are still having difficulty with the cosine law, see me, please. Notice all my good notation. 100, squared plus 500 squared minus 2 times 100 times 500 times 70 cos equals at the end 225 985 986 and square root 475.2. Now, if you want to be a pilot, you've got to be able to do all this stuff by hand, as well as all this stuff with the computer programs they give you. All right, so now we know the magnitude, we need the direction. So notice I don't put it here because that's not the center of the compass rose. I want to relate this to north, south, east, west. So sine of 70 degrees over his partner, the thing we just figured out, equals sine of, I don't know what theta is, but I know it's across from the 100 kilometers. So sine theta is equal to 100 times sine 70 degrees divided by 475.2. That will get me some hideous decimal, and then I will second function sine it, which is totally bad math language. Not second function sine yet. Awful number. Second function sine. 11.4. So, here's north. Swing it around. 40 degrees to there and an extra 11.4 degrees to there. So the angle that I'm concerned about is 40 plus 11.4, which is 51.4 degrees. And then I can write a therefore statement. Therefore, the ground velocity is 475.2, so it's magnitude with units and direction. So north swung 51.8 degrees in the east direction. And there you go. Hand cramp break. Okay, so this is the question that is online. It's pretty similar to the other questions, except it's asking for the airspeed and the initial direction of the plane, meaning that it's asking for the A with the vector hat and the magnitude rather than G. But you set it up the same way, and if you have any problems, please ask. Here is the last question we do. And I really like this. I know I always say that, but I really like this because it actually makes me know who really knows what's going on when all of a sudden it's not about a plane, it's about a boat. So, a boat heads across a river 5 kilometers wide, perpendicular to the current. So, I'm going to make the most perfect river there is, and I am going to make a completely straight banked river. So maybe it's a canal. And this boat heads perpendicular to the current. So the current is going downstream or upstream. I'm going to say it goes downstream. The current goes downstream and the boat is heading across perpendicular to the current. If the boat has a speed of 10 kilometers per hour in still water, so this is the exact same thing as airspeed. Because if I flip back to air, airspeed is a plane's speed relative to the air. So this is relative to still water, only it's boat speed. So if you want to change the letters, go ahead. I'm going to count it as airspeed and pretend I've got, I don't know, a boat that looks like a plane. A pontoon boat, a pontoon plane. Anyhow, the current is 4 kilometers per hour. So the current is going to take this boat, which is heading perpendicular to the current, and it's going to shove it downstream by some amount. And for consistency's sake, I am going to turn that red because that is the result. So let's put some numbers on here. This is 10 kilometers per hour. The current, which is kind of the equivalent of wind speed, is 4 kilometers per hour. I am looking for the result, which is the equivalent of ground speed. And something to keep in mind at some point, and it doesn't match any of the units anywhere in here, is that apparently this river is 5 kilometers wide. So on my picture, I have kilometers an hour, and hopefully kilometers an hour. And over here, I've got kilometers. So this is like a little bit of an anomaly. And the question says, determine the ground velocity of the boat. So I am going to put my theta here with respect to the shore. All right, so do you want to do sine law or cos law? And the answer is actually neither. Hopefully you get, because it said perpendicular, that you know you have a right angle triangle. So you can do the cosine law with 10 and 4 and 90 degrees. But because it's a right angle triangle, I'm going to remind you the existence of opposite, adjacent, hypotenuse, not the sine law and the cosine law, but the sine, cos, and tan ratios. And the first thing I can do here is actually, I've got two sides, I need a third. How about I just use the Pythagorean Theorem? So the hypotenuse squared is equal to the sum of the squares of the other two sides. For those of you who like to do the same thing over and over and over again, you could use the cosine law without a problem. So 10.8. And that would be kilometers an hour. So now I know how fast the boat is going. And I need to know the angle. So this is where old school trig comes into play. So I've got O and A, which is tan. So tan theta is equal to O over A. Tan, don't know theta, is equal to 4 over 10. Because this is a short one, I'll remind you that you'll have to do tan inverse like we've been doing sine inverse. And I'll come out with a theta. So 4 divided by 10 equals 0.4. Second function, tan, I get 21.8 degrees. So this is 21.8 degrees. This is 10.8 kilometers per hour. And for the record, ground speed is what you see when you're standing on the ground and you look up at the plane. So you don't know that the pilot is heading in this direction only to be pushed by the wind to get to where they're actually going. And this is what you see on land. The pilot of the boat, the captain of the boat, is heading the boat in that direction, only to be pushed by the current / wind over here to end up here. So what you see on the ground velocity, is that they end up here. You have no idea what's happening in the captain's mind. So you kind of have a choice. I'm going to do this. I'm going to say that this corner right here is 90 degrees minus 21.8 degrees, because I want this corner with respect to the shore. That's 68.2. So I can write a therefore statement that answers part A, determine the ground velocity of the boat. So therefore, the boat has a ground velocity of 10.8 kilometers per hour at, I'm going to say 68.2 degrees to the shore, which seems a bit more logical than 21.8 degrees to perpendicular to the current, which is a bit more of a mouthful. All right, so the last question that we get to do here is, how long does it take to cross the river? So this takes you back probably to grade 9 science, where I've just told you how wide the river is. I've told you how long it takes to get across the river, not necessarily perpendicular across the river, but definitely across the river. So what we can do is we can dig out the good old distance, speed, time triangle, or I guess in this case, distance, velocity, time, and it doesn't matter the order here. I am looking for time, so that is me taking distance and putting velocity underneath it. So the distance was 5 kilometers, the velocity is 10.8 kilometers per hour. 5 divided by 10.8 is equal to 0.4629, so I'll say 0.46. This was kilometers. This was kilometers per hour, so this is hours. So you can write your therefore statement to say that it takes that many hours, or you can times that by 60 and get 27.8 minutes. And then you can write your therefore statement. Therefore, it will take 0.46 hours or 27.8 minutes. Okay, so homework sheet. Hold on. Maybe you need another second there. Anyways, there's a homework sheet for homework on the Google Classroom, as well as, not Google Classroom, Google Site, as well as the solution for this problem. So Jake's trip, or whatever I would have called it. So let me just slash it out, site. And there you go. This unit is over. We go on and deal with Cartesian vectors next. So although I did make a grid in this question and this question, the grid wasn't necessarily to put on X, Y, and Z. It was to reference north, south, east, west. So Cartesian vectors is in reference to the x-axis, the y-axis, and when we get there, the z-axis. So just a little preview for you on that. Good night.